Hey guys, Paradoxio here. Welcome back to a brand new video, everybody. In this video, we are going to be going over the base Python data types that we can work with as soon as we install the programming language. Now, these basic data types include some of the really basic things that we're going to be working with in Python, such as strings, numeric data types, collections, etc. Now, this video is meant to act as sort of an extension to my full Python course video, but we're going to go a little bit more in depth with some of these data types talked about in this video. So for our first set of data types, we're going to be talking about the numeric types. And this is going to be our integer, floating point number, and complex number data types. Now first, let's get started with integer data types, or what's known as int in Python. Now int represents a whole number, like 4, 5, 1, 0, 100, 1000, etc. These just represent whole numbers that don't have a decimal point anywhere. So a decimal number like pi cannot be an integer. Now, way back in the day, forever ago, back in the dinosaur days, or otherwise known as the days where we only had Python 2, we actually had another data type, and that was called long. And basically, we had a long data type because back then, int could only support numbers ranging from -2 to the 31st power to 2 to the 31st power, or otherwise known as signed 32-bit integers. But a long was made to represent numbers larger than 32 bits. But now in Python 3, we essentially just merged int and long together. And actually, unlike some programming languages, Python does not have a set maximum or set a large size for how big a number can be. There is no maximum size for a number in Python. We can make our integer number as large as our memory can handle. So if you want it to be something like 1 million, million, do so at your own risk. Do it as large as you want to. We can make a integer number by setting a variable like x and setting it equal to 4. And if we want to be fancy and have a little bit better coding practice, we can type int it as a integer. And we can, of course, print our integer in the console, and we get 4. Now let's talk about floats. Floats is just like int, but float supports decimal point numbers. And essentially, a float is supposed to allow us to divide numbers that won't divide evenly. This is where we get a floating point number, that term, from, and it basically represents just a number with a decimal point that can be anywhere within a number, which is why it's called a floating point. Now, a float can represent numbers like pi, or 4.5, 3 3/4, 1.1 repeating, 0.5 or just 1/2, 1/3. Those are all floating point numbers. Now, when you divide two numbers in Python, it's going to result in a floating point number, even if the numbers divide evenly. So if we have 4 divided by 2, obviously it's 2. Even though that is going to divide into a whole number, Python's automatically going to convert it to a floating point number, just because that when we divide on a computer, it automatically converts to a float. Because, fun fact, actually computers suck at math. So we use the floating point system to be able to divide, basically. That's why we have that system in place for our computers to use. It's so that way we can perform division arithmetic. So even if you have a number divided evenly, Python's going to automatically convert it to a float. But, of course, we can try to convert it to an integer later on if we wish. Now, creating a float's just like creating an integer. set a variable like x. You can type into it as float if you want, and you can set it to like 4 point blah 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 blah. Pretty simple. Now our last numeric data type is going to be a complex, and this is to represent a complex number, or otherwise a number with a real and an imaginary part. And we can use this by first adding our real part, which can be 4, and then our imaginary part, which can be 5. And if we want to make these negative, we sure as heck can. And if I wanted to set this equal to something like x, we can do that, and then we can print our complex number. And as you see in the output, we get 4 plus 5j. Now in Python, the imaginary symbol that's usually I is referred to as j. So whenever we see j with a number in Python, that is actually a complex or imaginary number. Now, let's get out of the numeric data types and let's talk about the string type, or str, in Python. Now, a string in Python is technically a sequence. It's technically a sequential data type in Python because it's a sequence of characters. And we make a string using the double or single quotes in Python. And let's say I have a message defined by MSG, type into as a string, and I want this to say hello world. We can then print our message. And voila, we get hello world in the output. Now here's something else we can do with a string. We can actually add a character to the string through concatenation. So let's say I have hello world, and I want to type in message plus equals space, today is a beautiful day. And then I want to print message again. Now this should work. And look at that, we get hello world, today is a beautiful day. So we can concatenate two strings together. Now we could also do this with the join method. So let's say I want to type in message dot join. And let's say I want to add a character, maybe another exclamation point to add a little bit more excitement. We can then type in print message. And whoops, I forgot to type in message equals, so that way we'll be able to do that. Actually, hold on, wait a minute. That should do it. There we go. Sorry guys, it's been a little while since I really programmed in Python, but as you can see, we now get that extra exclamation point inside of our string using the .join method. There's also .replace. Maybe I want to replace our characters in a message. Maybe I don't want that exclamation point. Maybe I just want a simple period instead. So what we can do is we could type in exclamation point, comma, and then add in a period. And basically, we're going to replace this exclamation point with a period instead. And if I go ahead and run our code, we now get hello world with a nice period at the very end. We can also split strings at a certain character. So we could type in split. Maybe I want to split it at the comma. Run our code, and now we get hello and then world. And this space is included just because I have that right there. Pretty neat. Now let's talk about the list data type. List represents a collection of elements. This could be variables, objects, numbers, strings, other lists as well if you want to make a two-dimensional array or a two-dimensional list. We can put just about anything in a list. And let's say I have a list of names. I know I've done this a lot already in our course, but say I have a list of names like John, James, and let's do something like Joe. and I want to, you know, print every name. Well, I could just print list or print names. And look at that, we get John, James, and Joe printing the output. But what if I don't want those quotations and commas in those brackets? Well, we can use something known as a for loop to iterate through this list. So for name and names, print name, and then run our code, and now we get all the names printed into our output in a clean and organized manner. Now, what do we use lists for? Well, typically we just use lists for when we want to have a collection of a lot of different items. And these items could be anything. Maybe we're making a game and we want to have a lot of characters or NPCs running around in our game environment. Well, we could use a list to do that. Perhaps we want to manage a lot of different objects at once. Well, we could use a list and then a for loop to do that. We can also use a list for storing many different files through their file paths. We can definitely do that. There's a lot of reasons why we would use a list. I can honestly, just about any project you can think of is likely going to include some kind of list, or at least some kind of collection inside of it. Now let's talk about set and frozen set. So we have set and frozen set. Now, these are both set types, and we can create a set by just typing in set equals a set of curly braces. Goodness gracious, how many times am I going to say set? But okay, and these are going to be just like a list. It's going to be just like a list. We can have very many different items. The difference is that items or elements cannot repeat. So if I have 1, 2, 3, and then another 3, and I try to print that set, we only get 1, 2, and 3 because that extra 3 is truncated from the set. Now, actually, let's change this to my set, and let's type in this. There we go. And let's say I want to add another number to that set. Well, we could type in my set.add. Let's add a 4. And I'm not sure why keys were added into that. Tab 9 is just being dumb. But now we get 1, 2, 3, and 4 added to our set. We can also remove a number from our set. Let's remove 2. And then we get 1 and 3. Now, a frozen set is the same thing as a set, but we cannot use the add, remove, or any of the methods that are included with the set data type. So a frozen set is basically the same thing, but we can't do anything with it. We can't add or remove numbers. It's not mutable. It's just there. It's frozen in a sense. That's where it gets its name from, a frozen set. And we can make a frozen set by just typing in my set is equal to frozen set my set. And if I were to go ahead and try to type in my set.add, it should actually throw an error. Yep. So frozen set object has no attribute add, and that's because it's now a frozen set and we're not able to add anything to it. Now another sequential type or a collection is called a tuple. And a tuple is also like a set and also like a list. Now, tuples, typically we don't often use, unless it's just like a couple values. Perhaps we are dealing with a graph and we want to get the x and y values for a tuple. Well, or I'm sorry, x and y values for a line or a curve. I'm tired. But we can use a tuple to store those x and y values. So maybe let's say I have x is equal to 5 and y is equal to 2 times x. Just put a comma, equals 10. And then I have my, I can just type in point and set it equal to a tuple, which is done by setting it equal to a set of empty empty parentheses, and then we can just pass in that, or we can just pass in the numbers themselves, and we can print this point. Now, points has a count and index. And let's say I want to get the index of x. We can just type in index of x, set it equal to that. And we just type in index of x, remove that. And we can get the value of the index position at 5, which is at index position 0, so we get 0 in the output. So that's how we can use a tuple. Typically, tuples don't carry large amount of values. At that point, you might as well just use a list. But they're pretty cool to use if we're just dealing with something like maybe 2 to 3 values at a time. This is typically done with RGB color codes, X and Y values, and maybe some other stuff like a person's name, age, phone number, email address, etc. if you're dealing with like storing data for different people. Now, let's talk about range. Now, we've used range in our course. Now, technically, I've called range an object a lot in that course, and I realized I kind of made a mistake there because I may have confused some people on what a range actually is. A range is actually a data type, but we can treat it like an object. So if I wanted to type in x is equal to range, and then pass in 5, what that's really going to do is it's going to create a range of numbers. And it's going to create a range of 5 numbers. And automatically they're going to increment by 1 starting from 0 unless I specify where it's going to start from. And which I've shown you in that course. Now I can print x, but we're just going to get this in our output. Range 0, 5. Well, okay, well how do I fix that? Well, actually what we can do is we can convert x to a list so that way we can visualize our range of numbers. And as you can see, we have 5 different numbers here. 0, 1, 2, 3, and 4. Now we can iterate through this. For I in range 5, what we can do is we can just print I. And if I run this code, there we go, 0, 1, 2, 3, and 4. Alright, let's talk about a dictionary, or what's sometimes called an associative array or a mapping array in other programming languages. Now, a dictionary has a key and a value. So, maybe we have a person, and we want to set it equal to a set of curly braces, and we're going to pass in all kinds of information that this dictionary or associative array will have. Now, tab 9's asking me to make this pretty complex, and we can. But let's make it look a little bit nicer and a little bit easier. So let's say we have name, John Doe, and his age. Say he's 30 years old, and his gender is a male. Now, we have a dictionary, and if I go ahead and print person, we get name, John Doe, age 30, gender male. Basically the same thing we see here, but printed onto one line. Well, what if I want to print just a person's name? Well, what I can do is I can type in person, and then just like we would index at a list, we can just pass in name like that. Now we get John Doe. If I want his age, I can just type in age like that, 30, and then gender just like that, and we get male. Now there's also some methods like .get, and that's basically going to work the same as just indexing it at name. See, we get John Doe. And we can type in .keys, and basically it's going to give us a list of all the keys inside this dictionary. So we have name, age, and gender. And just like for the keys, there's also one for the values, which would print all the values of this dictionary. So we can use dictionaries just like we would tuples if maybe we want to store information for a person. Typically we use dictionaries a lot when we're working with JSON files if we want a quick way to save some data within our Python project. Now let's move on to objects or classes in Python. Now an object is technically a data type considered by most people because it has a lot of methods. We give it attributes or properties, and so on and so forth. So let's say I have a person. And I'm going to make a constructor method. And then I'm going to create a method like introduce self, and then print, hello, my name is... And actually, back to the string data type, we can actually insert values using the F string or the letter F in front of the set of quotations. Type in self.name here. And I'm actually going to... Can I do that? No, I can't. Whoops. Alright. I am... age... years old. Pretty neat. Now, let's say I want to create our person now. What I can do is I can type in my person is equal to person. And in here, we're going to pass in a name. Let's do John. And an age, let's do 30. Now, of course, we can type in name and age. To make age an integer because he can't be 30 and a half years old. Well, technically you can, but we're not going to worry about that. We're just going to leave it as an integer. And then let's say I want to print the person's name. So we can type in myperson.name. Now, of course, there are ways you can make this a private property or a public property. I've already shown you guys how to do that in the course, so I'm not going to go into that in this video. But that's how we can get the name, and of course we can do the same for the age. 30. And then let's say I want to introduce. So, introduce self, which is a method of our class. And if I go ahead and run the code, hello, my name is John, I am 30 years old. Now, I'm not sure where the none comes from. I think that might just be a weird bug in this code, but let's just pretend that doesn't exist because, as you can see, our method has worked right there. Pretty neat. So, that is how we can use objects in Python. So that is just about it for most of the basic data types in Python. Now there's also bool and none, but there's not much to really get into because a bool or boolean data type is just true and false, and a none data type is just none, which represents an absence of a value. Typically we can use this as a placeholder, or we can just use it to show that, hey, there's nothing for this variable, there's no value for it. Nothing really special to get into about those. And if you're curious, yes, none is basically the same thing as null in other programming languages. But that is it for this video. If you've enjoyed these Python tutorials, be sure to leave a like and subscribe to my channel. Leave a comment on what you might want to see next. If you're wanting to learn something else about Python, be sure to let me know. I might just make a video on it. Also, join my Discord server. We are just a little bit over 800 people. I'm trying to make it to 1,000 members by the end of this year. And also, feel free to create an account for free on houseofcode.xyz. That is the official website for this YouTube channel and my community behind it. On there, you can upload your own script files, create forums, follow other people, and just overall engage with the community. So again, if you've enjoyed this video, be sure to subscribe, and I will see you all next time. Bye-bye.